So privacy on the transaction layer. Here we define linkability and unlinkability. So this is one of the important privacy characteristics of a payment. If you look here, we have Alice and we have Bob, and they're both paying something to Charlie, right? Each conducting a transaction. And everybody sees the transactions go to the same recipient, right? That's quite important. Now, unlinkability means that we have no idea where these transactions TX1 and TX2 go. So we do know that Alice and Bob, they're performing two transactions, but we don't know the recipient. A second important privacy property is traceability or untraceability. Now let's assume we have here transaction 1 and transaction 2, and these go to address 1, right? And then the funds from address 1 go to Charlie in the transaction 3. So transaction 3 spends the funds received from transaction 1 and 2, right? So this means we can trace the funds. Now we would not be able to trace the fund if we have no idea where the funds from TX3 come from, right? So if we don't know about this origin of these particular funds, then they are untraceable. So transactions in the Bitcoin network follow the unspent transaction output model, as we know, right? So we have an input, and so we have n inputs and m outputs here. So we have a sender address, we have a recipient address, and we have a change address. And these are linkable and traceable, right? Because everything is public and we know where the money flows. So if we have a transaction 1 and we have a transaction 2, right, we can follow the funds here. Excuse me. So if you have transaction 1, transaction 2 here, we can follow this particular stream. Now, what about heuristics to cluster Bitcoin addresses into entities? So how can we take different addresses together and make them appear as an entity? So what we can see is we have change addresses. So if we know that there's a new address, then this can be likely a change address, unless there are two new addresses, so we don't know whether the recipient provided a new fresh address for the sender. What we can also do is we can have multi-input transactions. So we have all inputs from a given transaction are likely to be signed by the same entity. So given these two simple heuristics, we could then cluster addresses into different clusters of entities. And they might represent entities, but these again are only heuristics and we're not really certain about it. If we were to use these two heuristics and plot the number of addresses per entity, you can see here a plot, and you can see most entities only have like one address. But there are also a few, like 15% of the entities have two addresses and so on. And there is also a long tail where we have a few clusters that have many, so 40 plus addresses. If you want to perform such tracing for the Bitcoin blockchain, I can recommend you this GitHub-based parser. This parser from GitHub. It's a C++ version that is very efficient. If you want to look over the number of entities over time, so this is here published work from 2014, you can see how the number of entities have grown over time in the Bitcoin network. So is it really easy to trace funds? So there were some funds that were seized from the Silk Road server. So the Silk Road server, or the Silk Road, was an online forum where people were able to buy any kinds of goods that are legal or illegal with Bitcoins. And the FBI seized the server at some point in time. And this is here like a potential trace of how people try to kind of link the DPR or these Silk Road admin funds with the funds of a founder. Right? So it is possible, but it's not always very indicative of. I mean, it's not. There's not necessarily a proof of a link between certain between certain transactions. So I think what we can generally say is that there's a certain behavior of users that can be reproduced and that can be looked at. However, identifying a particular user or particular trace is challenging.